All right,
good, thank
you. So this is your first year, huh?
On the show?
Yeah.
Fully producing.
Mic check from the live shot. Mic check from the live shot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thank you very much.
Katie's going to let everybody know how they can get a hold of us.
Awesome.
I'll say a little something, and then I'll go time for today's math in the news. Graphic that goes up. Point, you come up. I'll wave to you, whatever. You'll stand where you are now. All right. But always, I want you also to remember, come close to the front.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Hey, we're here, Charlotte, home of the Eagle, and we are here to...
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Mary Lou.
And this is the beginning of season 18.
My
We are
goodness.
finally an adult. We're 18 years old now. Anyway, we have a great hour set up for you. As we just said, today is the first live program for season 18. We'll be with you on Tuesdays and Wednesdays between 4 and 5 o'clock. And there's a lot of different ways you can get a hold of us. Katie, would you like to let everybody know those ways?
For math homework help, call in Bakersfield 636-4357, toll free 1-888-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
Nicely done.
Yes.
There's a lot of ways you can get a hold of us, isn't there?
Yes.
Right? So a lot of kids will be watching online. So if you would like us to work out one of your math problems and you go, well, I don't have cable anymore, that's exactly why you can view the program online. So you simply give us a call, let the phone tutor know that you would like to see it worked out on live TV, and you can watch on the internet while we work it out for you. We have a couple of special guests in studio. Katie is one of them. So while you're here, why don't you let everybody know where you go to school and what grade you're in?
I go to school at Stockdale Elementary, and the grade I am in is 5th grade.
How's 5th grade going?
Good.
Kind of easy right now?
Yeah.
Yeah. What's the best thing about 5th grade right now?
We have different teachers for history and science.
Oh, you do. So you get to move to a different classroom, right?
Yes.
Okay. And how do you like that?
Good, because we get to learn from different teachers.
And that's always good. And get you ready for junior high, right? When you
Yeah.
go there.
Yes.
And then when you go to high school. And then if you keep on going on after that, right? It's always good to learn from as many people as you can.
Yes.
I have a problem for you to work on real quick. Are you able to do one very quickly for us?
Yes.
Okay. So this is a problem that came on the email. All right. It was a 3rd grade student, and their parent was helping them. And they said, why don't you go over to the board, actually, we'll write this out. It might make a little more sense for some students.
There you go, kiddo.
All right. So write the number in the middle, kind of large, 67. Now, each of those has a place value. Do you know what the place values of those numbers are right now?
Yes.
Explain to us what those are, the place values.
The 7 is the 1s and the 6 is the 10s.
Right, so we have a number in the 1s and a number in the 10s.
Yeah.
Now, the student had to say, round to the nearest 100. Well, there is no 100 place right now. So that's where the student was a little bit stuck. So how can we help this student round 67 to the nearest 100 if there's not even a number in the hundreds place?
Well, if 67, so it's higher than 50, so it would go to 100, and if it was lower, like 40, it would go down to the 10s.
Okay, can you show us what that looks like on a number line? What would that look like? So if we just did a quick, there you go. If we did a quick number line across, okay?
Yes.
So we have to round it to the nearest hundreds. So obviously, what's the next 100 after 67?
200.
Is it 200? What comes before 200 though?
300.
Before. Go that way. What about 100? Yes?
Yes.
Okay. And then we have 100 to 0, right? What comes in the middle?
50.
Okay, let's put 50 there. So using this number line, help this student explain, where would you round this to again? If we're rounding to the nearest hundreds, where would you go?
To the 100.
To the hundreds. Okay, we're not going to round it all the way down to...
The 0.
No. Explain to them why. Where does the 67 fall on this number line, making us round it up and not down?
So if 67 would go right here, because it's not lower than 50, so it wouldn't be 10.
Okay. So what's the key thing to always remember when to round it up? What's our key number here?
So if it's 50 or higher, 5 or higher, it goes, if it's 50 or higher, it goes up.
Okay.
And if it's 50, 40 or lower, it goes down.
Is it just 40?
No,
What's the number before 50?
49.
49.
Nine.
That's really important to know, huh?
Yeah.
Because you're saying 40, but we have the 41 and the 42. Yeah. We got to think about that chunk of numbers, huh?
Yeah.
So let's write 49. Whoop. Let's write 49 right before that 50. And let's go ahead and do our arrow showing down.
And I'll give you ladies about 20 more seconds.
So show it down this way. Like how I did the number up, we're going to round up. If it's 49, we're going to round down. There you go. So final answer, 67 has to round to
100.
There you go.
There you go. Nicely done. Hopefully that helps out that third grade student. Hey, we do have phone tutors available until 5:30. The phone numbers are at the bottom of your screen periodically throughout the program. Time now for today's Math in the News. All right, well, today's Math in the News is a little bit different. Usually we take one of the news stories and see how we can apply math to it and work on a math problem. Today we're going to talk a little bit about the math. In studio with us right now we have Mary Barlow. And how are you today?
I'm very well, thank you.
Why don't you let everybody know where you work and what you do?
Oh, I'm very excited. I am the Kern County Superintendent of Schools, and I have the pleasure of working with all of you, along with 47 school districts.
47 school districts. Now you are the superintendent of the Kern County Superintendent of Schools office. I'm sure Katie would like to know, what does a superintendent of a county do, or how do you become one?
Okay, so let's start with what we do. So we have individual programs that support students with special needs. For instance, students who might be orthopedically challenged, learning disabled. So those types of programs operate directly from our county office, as well as children who are in court and community school. Lots of individual programs just for those kids with the most special needs. Then we also support the 47 school districts that serve somewhere around 190,000 students across 8,200 square miles in this county. So we do whatever we can to make sure that they have the very best opportunity, every student in this county, to succeed. That's our job.
That's quite a job.
Yeah.
Now, you were talking about the land area, the size with all the districts and things like that, because I know that this county is basically the size of Connecticut.
Yeah.
So you're in charge of a county that is basically the size of a state back east. Now, you were talking about 47 school districts, and one of the things I know that you're involved in is the Kern Education Pledge with a lot of people that we as educators work with. Can you tell us a little bit about that also?
Sure, absolutely. I'm really excited about it. So it's a pledge that's signed by all 47 school district superintendents along with institutes of higher education. So President Lynette Zalesny from CSUB, Kern Community College District, Tom Burke, and others who are all committed to make sure that students succeed from cradle to career. And so what this does is it focuses all of our efforts collectively on specific areas to make sure that children read, well, they enter school ready to learn, that they read by the end of 3rd grade, that they are on track for math by the end of 5th grade, and that in 8th grade they are prepared to enter high school. In high school, they complete the requirements necessary for CTE career technical education
Okay.
or college preparedness. And then once they get into college, that they complete, get a certificate, and enter the workforce.
Productive citizens.
Absolutely.
And that is the goal of the county office and all of the other districts that fall within your
Exactly.
realm, let's say,
It's-
their jurisdiction, or however you want to word that. Now, in order for students to do well at that, attendance is a big thing.
Absolutely.
So the attendance awareness month that you have going on started at the beginning of school, obviously, and coming into September. So can you explain a little bit about that, how that started and what that entails?
Sure, absolutely. Been working on it for a number of years. It's absolutely critical for students to attend school. If they miss a 10% or approximately 18 days a year, that means that they are more likely than others to not succeed. What that means is not reading at 3rd grade, not reading at grade level, not finishing high school, and in fact, probably not getting a diploma and being able to enter the workforce, and their earnings will be impacted.
And that's with only 10% missing.
Right, 10%. So if you think about it, it really means a day or two a month. And so it doesn't seem like much, but it adds up fast. And so we have a campaign that's called Strive for 5. So less than 5 school days a year should be missed, no more than that. And typically we need to kind of take a look at the reasons why people miss school. Sometimes it's things we can avoid, like scheduling dental or doctor appointments after school.
Right. Do those at 3 or 4 o'clock in the afternoon when you
Exactly,
can. And a lot of
yes.
places will accommodate you, knowing that the child needs to be in school.
Absolutely.
I remember that was one big thing. Our personal kids, but our oldest made it all the way from kindergarten through high school and college
Wow.
without missing a day.
Wow, that's
He even
commitment.
brought to task an instructor who missed a day because of something came up, and it wasn't anything big. And he said, "Listen, I'm paying to be in college. You need to be here.
That's
The reason you
terrific.
weren't here is not a good reason. So if I'm paying for you to be here, you need to be here." But he and a lot of students realize early on that attendance is very important.
Absolutely.
Towards the ultimate goal of graduation. And I know Katie has a question for you.
If graduation is important to all students in schools, what is being done to make sure more kids graduate?
That's a terrific question. We are seeing increased graduation across Kern County. Our rates are, in fact, a little bit higher than the average in the state of California. And the reason for that is focusing on attendance, as well as making sure school is interesting so that students want to attend every day. So what kind of additional activities do we have after school? Are there links, direct links to career technical education and opportunities for students after they get out of high school? So we're making education real for them and important to their everyday life. We're working very, very hard with students and teachers in the classroom to make sure that they improve student outcomes with math and English language arts particularly. So those are just some of the things we're doing.
All right, nicely done. And you know what? We know that you're a busy person, and we don't want to take too much time away because there are 47 school districts waiting to tug at you in all different directions and things like that. But once again, we would like to thank Mary Barlow, the Kern County Superintendent of Schools for Kern County, for taking a few moments coming down. And that is today's Math in the News. 636-4357 is that phone number. We will be doing some problems with Katie in here in just a little bit. But right now we have our Science for Kern, and they're out at Berkshire Elementary today with Scott.
Hey, welcome. We are here at Berkshire Elementary. We're so excited to be here today because my friend Michelle, and we want to know what's going on here today, Michelle, because I'm pretty excited about what's happening. Can you tell a little bit first of all about science?
Science for Kern is a mobile lending library sponsored by Chevron. There are currently 10 science units that teachers in grades 4 and 5 can check out through the website. It's Kern.org. The units are available there for checkout. The Science for Kern units, just the demo lesson. And then leaves the lesson for about 3 to 6 weeks, depending on how many classrooms are using the unit. And then we come back and pick it up. and get it all ready and send it out to the next teacher.
What a wonderful supplement for a science teacher who obviously has a lot to choose from, but this stuff is just almost prepacked, ready to go.
Yes, and it does
Hey, there you go. You can't beat free. That's the way to go right there.
there's absolutely no cost to this.
And I know you have a passion for this. I can tell already. I would love to see you get this lesson started.
All right.
They have a little prep already, but they're ready to get to the hands and the fingers and the touch.
So as you saw, we were talking about earthquakes
Right.
prior to Cameron joining us. Because we're talking about yeah, we had a great conversation about their experiences of the pertaining to earthquakes and earthquake safety, and we were talking a little bit about earthquake retrofitting here in California. So we proposed a challenge, and the challenge is this: that they are going to use. All the students have a bag of 30 plastic coffee screws and some clay, and they have this manila folder for the students to bring. And their challenge is to create an earthquake safety structure that's 8 inches tall. That will survive, collapse, not fall down on an earthquake simulate earthquakes in here. So,
I can just imagine the reactions even before they happen. It's going to be great.
it's going to be great. So, students, you have had some time now to have some collaboration with your partners in your group. So now, are you ready to start building? Yeah. Do we have some ideas? All right, so remember, you have your manila folder piece, your piece of sturdy paper. What's this for? The ground. The ground, right? So that we can move our structure over to the earthquake simulator when we're ready. And then you have clay and straws. And your challenge is to go how high? 8 inches or more. Excellent. So are you ready? Okay, let's build. And while you're building, we're going to come around and talk to you about your plan. All right, are you ready? Yes. Let's start building. You guys can open up those bags. All right, folks. Can you tell us a little bit about your plan here? What are you planning to do?
Exits.
So, exits. Cool. I'm intrigued. Tell me about that.
We're planning to do like a type of square, the 3D circle.
Square. Okay, so where will the square be? On the bottom, the sides, the top? Tell me a little more.
So I know we gotta start. Miranda, you wanna? We're gonna do it's gonna be 3D. Like we're gonna do it like this on each side, and even on the bottom.
Good idea. I like it. And I noticed that all of your plans have something in common. You have those squares, right? But you also have these X's. Who came up with the fact that you're going to put X's on the side? Why? Why do you have X's?
I feel like it's going to have more balance.
Okay.
It's gonna hold it more.
Okay, it's going to hold it more. Okay.
What do you think about the structure of an X that might give it balance more, make it stronger? Is that what you said? Yes. Why do you think an X might be stronger?
So instead of just an open square, it's got more stuff inside. So that definitely seems like it would add something to it. I like this. It's almost like you thought about it a little bit. It's a good thing. Before you start building anything, you got to think about it. So I'm glad you did that. That's great.
That's excellent. All right, so you guys can start building and we'll come back and check on you. All right, so tell us a little bit about your plan.
To make it like a 3D image as a square, but as a 3D image with with our material, which is clay and
So what do you mean by 3D image? Tell me some more about
like we're gonna put square right here and we're gonna put a bunch of sticks around to make it look like a house.
Okay.
Like to make it look like a house. Whenever it shakes, it won't fall. It's not really,
Oh yeah.
like it's not really that. With all of them together, they might make it way better, or like stick it like that.
Go.
And it could be
I'm
way
glad you're testing it.
All right, excellent. We'll come back and check on you. Let's see how our next group is doing over here. All right, tell us a little bit about your plan.
We're gonna make a very tall square.
A very tall square. What do you mean by that?
We're gonna make the bottom like the base of the square, and then we're just gonna. I don't even know how we're gonna build this. We're just gonna make it tall.
So what shape are you going to use on your sides? So I see a square going down for the base. How about the sides?
Probably like this.
More squares?
Yes.
What about that?
I'm going to go together.
I see.
I see some similarities, and I'm excited to see what they're going to do. This is going to be like an ongoing deal as we go through the show, so I'm excited to see what they do. But I also know that there's some editing in this video. So, Mike, we're going to turn it back to you in the studio, and I'm sure there's some wonderful math problems to be done with your guests.
Scott and Michelle with the folks out at Science for Kern and the students at Berkshire Elementary. Hey, we do have phone tutors available until 5:30 this afternoon. The phone numbers are at the bottom of your screen periodically throughout the program. We have Katie, a 5th grade student from Stockdale, in studio with us, who says that 5th grade is going rather well so far and is pretty easy at the moment.
Yeah.
The key words, at the moment. Okay, so let's take a look at some of the math that you're working on right now. So why don't you ladies head on over to the board and we'll go ahead and take a look at it together.
Which color can we
So the
do?
first one says express as decimal numerals. The first one is done for you, so that's no fun. Let's go on to the second one. 24 thousandths. All right, and it sounds like I overemphasize that because we need to remember that those last 2 letters are different than thousands, it's thousandths.
Yeah.
So if you could explain that a little bit, we want 24 thousandths expressed as a decimal.
So if it's 24 thousandths, it would be this a 0.020. Because the thousandth, it has a th at the end, which is thousandths. If it was thousands going to the left, it would be 24 and then put a 0. But since it has that THS is in the dividing.
So this represents a number less than 1.
Yes.
Yes?
Yeah.
So what you're saying is if we didn't have that THS, because those are the bells and whistles that go off, huh?
Yes.
Then we know that that would be a very large number.
Yes.
Greater than 1.
Yes.
But because of the THS, it is less than 1.
Yes.
Okay. So what place value is this?
This is the tenths. A tenth.
Okay, what is this?
The hundredths.
And this is the?
Thousandths.
Okay. So what strategy would you tell everybody to use when they're writing it from word form to number form? What's a good strategy to help them remember place value?
So I learned that there is the decimal sign also, and then you can use a place value chart, which is very helpful if you're having struggling on how to move it.
Would these lines help you out, kind of remember?
Yes, and you could remember that it's the tenths, hundredths, thousandths, and if it doesn't have that THS and it has an S for thousands, it would go over here from the decimal point.
So it's the bigger number. Okay. Is there another one for us?
Yes, we're actually going to go on to the next one.
Okay.
C on this one. So this one has a little something different in it. So it's 1 and 324 thousandths.
1 and
300.
Whoop. Oh, see,
You can write this out in word form.
I know. I was trying to
here we
write
go.
the answer. See?
So 300.
100
Yeah.
or hundredths?
124 thousandths.
Excuse me. Okay, there is our THS. So keywords. Look at this. Keywords right now. What are keywords that we need to underline?
Okay, so the and, which means the decimal point.
Okay.
So it would be 1 decimal point, and then we would have to read this. So 324,000.
So how many lines are you thinking right now?
3.
3. What's the clue that tells you 3? Is it the number 3 here?
Thousands, because when you're going from the decimal points, it's only 3. Because if it was this way, there's a ones, then a tens, then a hundred.
But again, that word and tells us we have a
Decimal.
So we have, what place value is that again?
Tenths, hundredths, and thousands.
Okay.
So since 300 would be 324 thousandths. And then we would just write the 24.
There you go. You make it look very easy. Good job.
She's a master thus far.
she is.
So, place value, easy enough with that decimal in there. And the key was that word and means you need to put a decimal point in there. Sometimes when people read numbers, they go, well, 148, when they mean 148. Because 148 means one decimal 48.
Yes,
Okay?
way different, because that is a lot of times, you're correct, a lot of times when we say our numbers,
Yes.
we throw that and in there when it's not supposed to be.
So let's take a look at one more. So this is going to be something a little bit different. So you've been working with decimals, now we're going to go into fractions. Express 29 thousandths as a fraction this time.
29 thousandths as a fraction, so it would be just 29 at the top, and then thousandths is just a thousandth at the bottom. And
So now write that as a decimal.
okay, so that would be 0.0.
Again, the biggest thing is write it as you
Go.
read it.
Yes.
That's why fractions and decimals go hand in hand,
Yeah.
right? Any other clues for that?
If it is a fraction, that means it's not in front of the decimal point. It's always going to be at the back.
So it's less than 1.
Yes.
Again, it's a number smaller than 1. Think of it as, when we talk about money, change.
Yeah.
It's your change, right? But there's another clue. Look here. I'm going to do this real quick. Let's go green. Look at this. How many zeros do you see here?
3. So we don't put another place value chart for thousands because when we're going this way, there's not a 1. It's just tenths, hundredths, thousandths.
And how many place values is that?
3.
And how many zeros do you have?
3.
Could that be a strategy to help you
Yes.
out? Yeah, there you go.
Nicely done, ladies. I'm glad you're working with decimals and fractions right now because 5th grade is going to be loaded with
Yes.
decimals, fractions, and percents. So that might be something we work on a little bit later on. Anyway, we do have phone tutors available on most Tuesdays and Wednesdays throughout the regular school year from 3:30 to 5:30. Also, you can check us out online at dothemathonline.net. And for doing some excellent work right there, we've got a free little meal courtesy of our friends at Chick-fil-A for you for that. Have you ever been to Chick-fil-A?
Yes.
That's good stuff, isn't it?
Uh-huh.
I'll tell you, the old man loves that stuff. We'll be back with more right after this. Today we're at South Fork Middle School, home of the Mustangs, and we're here to All right, well, today we're at South Fork Middle School with some 6th grade students and ready to get busy on a math activity. You guys ready? Yeah. All right, here we go. So you've all got pencils. When you get up in the morning and you look in the mirror, what do you see?
Us.
You see yourself, right?
Yeah.
What is that called when you see yourself?
A reflection.
A reflection. Oh, you guys are perfect. You guys are on it right now, all right? So each of you take a paper and just go ahead and pass it down. All right? So what you're going to do is you're going to play with the person opposite you. Okay? So the one sitting across from you, not next to you. All right? And actually, the people on my right side, you won't need your paper right now. You're going to use yours for the second round. All right? So what I'd like you guys to do right now is fold your paper in half. So you can do it horizontally or vertically. Either way is fine. And since it's a square, it won't matter. All right, and then open it up.
And you can see where the crease is down the middle, right? Okay, so if we drew something on one side and wanted to make it look exactly the same on the other side, what would that be? A reflection of itself, right? So what I'd like you to do is on the left-hand side, so situate your paper so that it's left and right, okay? Down at the very bottom in the corner, put A on the left-hand side, and on the bottom on the right-hand side, on the other fold on the far right side, put B. That's going to be player A and player B. All right, so you guys are going to be player A, you will be player B. So on the left-hand side, what I would like you to do is I want you to make 5 marks. So you guys have another pencil around I can use? Yeah. All right. So imagine I've got my paper like this, it's folded. And on one side, what I'm going to do is I'm going to make 5 marks. Okay, it can be anywhere on the paper as long as it's on your side. So you guys go ahead and make 5 marks on your side of the paper, your player A. Anywhere at all, and make them kind of the same size. So you can see it's not just like a little dot. You want to make it a little bit larger than that. So about that size would be fine. Once you're through, pass the paper over to your partner, and then you girls go ahead and put 5 marks on that as well, on your side, player B. Oh, there's your pencil. So just take a colored pencil. Now, you didn't have to make it look like a reflection. If you did, that's fine, okay? What I want you to do now is you're going to, on your side of the paper, okay, so you guys can just hold on to it for right now, all right? So you're going to be on player B side. What I want you to do is you're going to look at player A, their side, where they have their marks. So if I was player B and I'm looking at his mark, I would think that in order to make it the reflection of his mark, I would want to point right about here. So what I'm going to do is I'm going to put a mark like this. I'm going to make a hole in the paper where I think his mark is going to be. So then what I do is I close the paper and I take a colored pencil and I make a mark inside that hole that I just made, okay? Then I open it up and I see how close I was. Was I close? Not really, I'm kind of far away, right? So I would have to think, all right, do I need to go farther in this way or do I need to go farther out that way in order to hit his mark? Does that make sense? Yeah. So when you look at your side, right, you're going to make a mark, okay, to see that when you fold it, will it hit their mark? It's kind of like Battleship. Have you guys ever played Battleship?
Yeah.
Yes.
Same thing, but with a piece of paper, all right? So go ahead and try that right now with the partner that you've got, all right? Make a hole in the paper on the side so that when you flip it, you think you're going to hit their mark. And when we come back, we'll see how the kids did with the first lesson on reflection. And once again, a big thanks to all of the staff and students that helped us out with Do the Math out at South Fork Middle School. Have you ever been to South Fork?
No.
That was my first time also, and I'll tell you, the setting that they have is beautiful up there. With that mountain, I mean, it's just a beautiful campus that they have at South Fork. So once again, thank you very much to all of that staff and students for helping us out, do a little math in your class. As always, we do have math tutors available until 5:30 this afternoon. We'll be going out to Berkshire Elementary for the Science for Current Challenge. But what they're working on has to do with something that happened earlier this year. Do you remember during the summertime, around the 4th of July, yes, major events here in Kern County?
Yes.
Do you remember what that was?
Yes, I do.
It's been a long time since, from New York, have felt an earthquake.
I was on the road, I missed that.
Yeah, so let's take a look. We've got some footage right here about earthquakes.
A series of powerful earthquakes tore and shifted the sandy earth of California's Mojave Desert in early July. A magnitude 6.4 earthquake struck near Ridgecrest, California on July 4th, followed a day later by a magnitude 7.1 quake to the north. The second event created a surface rupture 30 miles long that cut through Naval Air Weapons Station China Lake, a 1 million acre military installation. Sentinel-2B images show not only the rupture, but movement of the land itself. The ground west of the epicenter moves slightly northwest as the eastern side moves in the opposite direction. The pattern aligns with radar analysis from NASA's Jet Propulsion Laboratory, estimating that each side of the fault had shifted 2 feet or more from its original position. Government and satellite data will be used by the USGS and other agencies as they work to fully assess the impact of the California earthquake sequence.
Dramatic footage right there. When you see the road in two different directions and things like that and split like that, and you were just saying you were on your way to San Francisco when that happened. So you're thinking, all right, this is great. I'm going up to where this is a major area of this happening. Do you remember, were you in town when these earthquakes happened?
No.
No, you were lucky. I was in the backyard for one of these things, and I was like, well, what's going on? I was like, so we got through it. But anyway, the students at Berkshire Elementary right now are working on their Science for Current challenge. So we're going to go back out and visit with Michelle and Scott.
How's it going?
And Mike, you know, I was down this year when that earthquake happened, and boy, things were wrong my house. I'll tell you that. The pool was sloshing around, the vehicles were even moving on the driveway. So I'm with you. This is something that's close to home. My lesson a lot. It's really neat. Plans have changed, so we're going to see a bit of that, right?
Exactly. And the fact that we're building on a piece of the students have been using the yellow cardstock to actually do some testing as they're building, which has really been super helpful. And actually, some of these are on their second and third iteration of their structures.
What a great way to learn.
Exactly. So let's have this group here. All right, students, can you tell us a little bit about what you've done? Why? Tell us a little bit of why you have engineered your structure as you have.
Basically, did it just make like a house and then make pyramids to hold the structure up, and now we made supports right here on all four.
All right. So how are we doing on height? Are we 8 inches up? Did you meet the 8-inch constraint? Let's see. Did you make it? Where's it? You tell me. All right, so measure over. Let's see. What do you think? Ready to go? What do you think? On that side? Are we there? All right. So have you done any testing yet?
No, we're just trying to build
So how about if you shake the ground just a tiny bit? What do you think? Do you see any faulty spots where you think you might need to add some reinforcement? What do you think? All right.
right here and right here.
All right. So it looks like you're tall enough, but it looks like we need to work on turning it. Good job. All right, how about here? How are you doing? Whoa, the most unique structure in the room. All right, so how tall?
It's 8. It's a little bit more.
Are we there yet?
Because we measured it also by the papers.
Oh, excellent. Yeah, we used the paper strategy. Are we at 8 inches? All right, so have we tested it all? So we hit the 8-inch constraint. How about the shaking constraint? How's that going?
He's been practicing. I like it.
Okay, so let's hear from someone in the group about why you think your earthquake is doing so well.
Well,
What is it about your design?
we were thinking of a pyramid, so we tried that because our square wasn't working, like a house. So what I did was, I was thinking like, oh, this is not gonna work, can't do it. Then I kind of thought, and I kind of arranged the pieces a little bit in my mind, and then it just came to me. And then, so when we made the pyramid, we needed to think, oh, it's gonna be sturdy, it needs to be tall, it needs to survive the earth. So we really, we kind of just came up with it.
All right, so an engineer who takes his inspiration from the real world. Awesome. All right, so let's look at this group as well. So let's measure. Are we at 8 inches? Are we at 8 inches? Yeah. Okay, go stick it right there. Are we at 8 inches?
Yeah.
Okay, we're at the 8 inches. Have we done any earthquake testing yet? All right, demonstrate.
Let's see. Here you go.
Whoa!
Whoa!
Good testing.
Okay, so we were talking during the break about 23 seconds is how long the earthquake shook this summer. Did you guys try to shake 23 seconds?
Yeah.
Do you want to try? So count. Are you ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Look at that. You have almost gotten to where the earthquake lasted this summer. Incredible. All right, so maybe this one will work on going even higher.
That's right. We'll go even higher, and hopefully, if you have anything to add to it, make sure you get that done because the test is coming. Right? The test is coming. We need to test these things out on the official small scale earthquake simulator that we have here prepared for the next thing. So we'll be back in a minute to try out all of the designs that we have so far. Back to the video.
Thanks for that, Scott. Thanks to Michelle out there and the students at Berkshire working on those structures where they're making sure that they're able to stay steady. Anyway, we do have phone tutors available. Phone tutors are here until 5:30 this afternoon. And we're actually going to go to the phone right now. And Caitlin, how are you this afternoon?
Good. How are you?
I'm wonderful. Caitlin in studio was wondering how she was doing also because you both named Caitlin. When I said, Caitlin, how are you doing? She said, I'm doing well also. So you are now Katie. This is Caitlin. That's how we're going to differentiate between the two of you. Now, Caitlin, are you the same Caitlin that we had visits with a lot last year?
Yes.
Nice to hear from you again. So you're at Warren. And how is 7th grade right now? Because this is the first year in junior high, right?
Yes.
How is it?
Good.
Okay. What kind of math are you working on?
We're working on multiplying and dividing positive and negative integers.
Okay, so let's go ahead. If that's what you're working on right now, you can just read it, and Mary Lou's here to help you out.
Okay. Absolute value minus 5 minus 3.
Okay, is it this? Absolute value of -5?
Minus 3.
Is the -3 inside the absolute value?
Yes.
Okay. So we have -5 minus 3. Do we close the absolute value?
Yes.
Okay. Is that it?
Plus, open parentheses, -6, close parentheses, minus 12.
You got a lot of negatives in there, don't you? Okay, so let's think of Caitlin, our PEMDAS, right? Please excuse my dear Aunt Sally. However, what you really want to take care of first is your absolute value right here, okay? Because we have no multiplying, we have no dividing, we have a parentheses, but what this is doing is this is isolating that -6. This is -6, it's isolating it, okay? So let's start with your absolute value. Do you know what the definition of absolute value is?
It's, everything is positive.
Well, not always. Not everything always is positive. But the real definition of absolute value is how far is this from 0, okay? So the first thing we want to do is solve this. We have -5 and we're taking away another 3. So if we think about a number line, right? If this is 0 and we are at -3 there, we're taking away another 5, right? Or we're at -5, let me do that. We're at -5, we're taking away another 3. And you know when we take away, we're moving constantly to the left, right?
Yes.
So Caitlin, what's my solution here? -5, we're taking away another 3. What's that solution?
It equals -8.
Right, but that's absolute value of -8, okay?
Yes.
Then we have this. I'm adding a -6. Now, I don't know about with your teacher if she likes the double, but what we're really doing here is we're taking away 6, aren't we?
Yes.
That's what we're really doing. We're taking away another 6. So you really don't need the double operation symbol. You really don't need that plus negative. We know that we're taking away 6, and we're going to take away another 12, okay? So to help yourself, because a lot of times students get confused over that double operation. We're really just taking away 6. Let's take away the plus sign because we don't need it. But here, we still have this -8 we need to take care of. And again, absolute value says how far from 0 is -8? Well, -8 is 8 spaces away from 0, right?
Yeah.
So this just becomes a +8 because it's just 8 spaces away from 0. That's all I want to know. How far from 0 is this? It's 8 spaces. So we have 8, subtract 6, subtract 12. So you could use any property. You could do the associative property where you want to solve the front or solve the back. You could do the commutative property and move things around. What do you want to solve first, Caitlin?
8 minus 6.
Okay. What's 8 minus 6?
2.
Okay. And now we're going to take away 12. So am I going to end up with a positive number or a negative number?
Negative.
Okay. What am I going to end up with?
Negative 10.
Negative 10. There you go. Now, let me tell you when absolute value is not a positive. If we had this, what this is saying is give me the opposite of this answer. We know this answer comes out to be 8, right? It's going to be 8. But what's the opposite of that answer? -8. So again, we know that this answer needs to be that. But it's saying give me the opposite of this answer. And the opposite of this answer is -8. So the only time that your absolute value is going to be negative is when you have the negative. Oh, something froze up on me there. When you have the negative on the outside. Okay? And there you go. And your answer again is -10.
Nicely done, Caitlin. Thank you very much for that phone call. And because that was such a great call, we're going to award you a couple of tickets to go see a game of your choice at the Bakersfield Condors. So congratulations on that. And your circle did appear later on.
Yeah,
It may
I
have
saw
just
that.
taken a little moment to do that. Hey, we do have phone tutors available until 5:30. However, we have Katie in studio ready to do some more work. Are you ready?
Yes.
Yeah, you've been hanging around a little bit. Get back to work. Get over to the board, sister. Let's go. All right. You've been working with decimals and fractions a little bit. Okay, so now we're going to step it into percents. So I would like you to choose a 2-digit number between 10 and 90.
68.
68? So write 68 up on the board. Now, what I'd like you to do is I would like you to write that as if we had 68%. And then you need to turn that into a fraction and then turn it into a decimal. So if you're stuck on what I want you to do, Mary Lou is right there to help you with percent. You'll be doing a lot in 5th grade.
So what do you think the word percent means?
Add that sign, that means percent.
Uh-huh. That sign means percent, but what do you think the definition of percent means?
Like, you use it on tests and like.
Yes, you're right. You use it on tests, right? Would you be happy with the 68%? Yeah, I know, I wouldn't either. But we use it on tests. Now, what the word percent really means is per 100. So if I had 100 boxes and I shaded 68 of them, I shaded 68%. I shaded 68 boxes out of 100. Knowing that information, how would you write that as a fraction?
So that would be.
It would be 68 out of how many?
100.
Okay. You just changed a percent to a fraction because this means 100, hundredths. So now, how would I write this as a decimal?
So we would write it as a decimal as 0.68.
What do you think of percents?
Easy.
It's everything you're already doing, huh?
Yes.
What does this mean again?
Out of 100.
Hundredths, right?
Hundredths.
It's hundredths. It represents hundredths.
Yes.
So now I'm going to take another level, okay, with the fraction. Because when we deal with fractions, we always have to simplify. Do you know what that means?
No.
Simplify means that we are going to divide it by a common number, okay, and go all the way down that we can. What number do you think goes into both 68? I could divide them both by. Well, think first. They both end in what type of number? 8 and 0 are what kind of numbers? Even or odd?
Even.
They're even, right?
Yes.
They're both even, okay?
I'll give you girls 90 seconds.
Oh, okay. They're both even. Oh, so if they're both even, I can divide them by 2. Cut it in half. What's half of 100?
50.
Very good. Do you know what half of 68 is? 4. There you go. And then if we're going to keep going, we could even cut those in half again because 4 and 0 are even numbers. This is what is coming your way. Okay? But again, percent means what?
100 out of 100.
Hundreds. You got it. There you go.
So you've still got a moment.
Oh, we have a moment. Do you
So
want me
you
to
can-
finish this?
Right.
Okay, let's chop this in half. So we're going to cut it in half. What's half of 50?
25.
Awesome. Now let's think what is half of 34. Half of 3 is about 1, right? It can't be 2.
Yeah, okay.
It's about 1, okay?
Yeah.
So if I take that extra little 1 here from the 2, right? Because half of 2, what's half of 14?
7.
And we're done. We can't do anything more. I can't go any more because both of those numbers are odd. And 1 is the only number that will go into both of those numbers. Okay?
Got
There you go, nicely done. So a little bit of work with all 3 of those, decimals, fractions, and percent. Now, when Mary Lou said, would you like to get a 68 on a test, you were like, no. But I didn't tell you that was part of it. If you were going to choose a number between 10 and 90, like I said, and it was going to be one of the grades on your test, what would you select then?
90.
90, okay, that's good. I just wanted to make sure you were on the right track with me there, okay? All right, we do have phone tutors available until 5:30 as we do most Tuesdays and Wednesdays throughout the regular school year. We have another opportunity right now. We're going to go back out live to Berkshire Elementary and our friends Michelle and Scott with Science for Kern.
Hey, thanks, Mike. We're back here, and I have to agree that I would think I'd choose a 90 score as well. Hey, one of my favorite parts about this activity, as we go around, not only are we going to find out if the structures will hold up to earthquake, but notice all the yellow and green hands. It's a very cool interactive activity where the kids can build some things. So, are you ready for our first structure? Let's see if it holds up to the earthquake.
Well, all right.
This is our earthquake simulator. There's a little ruler on the side.
And let's add an extra constraint just for extra drama. How about if we all count 10 seconds and see if the building will withstand a 10-second earthquake? Are we ready?
Sounds good.
All right, so grab on. Ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Hey, nice job. Well done.
Well done. Let's give them a hand.
Good stuff.
So, what do you think was the key to success of that structure? We did not crumble.
Well, the idea was we were first going to make a square, so it kind of be a cube, but it started collapsing. So we went with a different kind of design, and when I put the sticks together, they made a pyramid, and it was almost 8 inches, but it wasn't exactly 8 inches. But I remembered what you told us, that the paper was like this was actually 8 inches. So what we did was we measured it all the way, and then it was slightless all the way to the 8 inches.
Good.
That's
Almost like
excellent.
you have
So
an
it's a
antenna.
pyramid with a tower. Well done. All right,
round
so put
2.
your structure on. Put your structure on the shaker.
Let me see your hands. Who was the ultimate builder here? I will know real quick. Let me see your hands.
We cleaned our hands.
Oh, you cleaned them up already. Okay. I was going to say, whoever has the greenest hands was the one who built the most on this one.
All right. So
Okay,
ready?
here's the shaker.
Everyone, get ready
Ready?
to count
Here we go. We're
with
gonna count
me.
again.
Ready?
Go.
Set. Go.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
All right. Well done. here. So what do you think in one sentence, what do you think the success to this shape, your design there?
We tried making a house.
Okay.
So it could be like whatever house we said. Testing it. But it turned out to be good, so we just like left it from there.
Okay, so if your house can withstand, the shape of your house can withstand an earthquake, you built something like a house, right? Excellent. All right. Move to this group. All right. Move that structure on top.
That's a great design right there.
What did we call this thing?
Tower of Life.
Tower
Tower
of
of Life.
Life. All right. Shake. Ready? Grab on. Ready? Set. Go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
We got 9 seconds out of it.
That was
So
a
good for a
neat
short
one.
earthquake, not so good for a
Yeah, this is a great structure, everyone, for a short earthquake. Well done, guys. All right,
we have a house looking one over here.
how about here? Lift your structure on. And let's clip it on. All right. Ready?
Who's our shaker?
Where's the shaker?
The honorary shaker coming around.
All right, ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yes, as long as you don't want a roof, you're fine.
Yeah,
Good.
well done. Yeah, your roof
We'll work on that
sort
part
of
a little
started to
bit,
come
but the rest
apart.
of it, I like the solid base there. That was, and it matches the foundation too. That's good.
Excellent. So what shape do you think was the key to success on that structure?
I think the right here.
Yeah, the
supporting
outside
parts.
supports.
The anchor to the ground?
Yeah.
Okay, excellent. All right, ladies. Another interesting structure here on top. All right, go ahead. I left my clip. Oh, I got another clip right here. Left my clip behind. You guys ready? Mm-hmm. All right, let's see how the Christmas tree building works. Ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Nice.
Excellent, ladies. So what do you?
Patrick from SpongeBob made it himself.
Patrick was the key to success there.
Yes.
You think those triangles had something to do with the
Yeah.
success? All right, last group.
See what you got. Ready? Put that up there. We'll clip it on.
Stick that structure there. We'll clip it on. Ooh, lift on.
Nice. Okay. Who's the shaker?
Set, shake. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, we have a little sagging there. Just a little bit.
Just a little minor collapse.
That's
there,
right. That's right. As long as there's some really short people in this house, we'll be okay.
Right.
Wonderful,
Really short
wonderful job. We
earthquake.
really enjoyed being here, and such an excellent activity for allowing students to make a plan, execute the plan, try it out a little bit, right, and then be able to use their hands and learn some things. So,
Exactly. Lots of iterations
Yeah.
going on here in
thanks
this
for your
engineering
time.
challenge.
Thanks for your time. Love Science for Kern. Can't wait to come back again, but right now we'll head back to the studio.
All right, thanks for that, Scott. Also, thank you to Michelle and the folks from Science for Kern for going out to Berkshire Elementary and doing that great activity with the students. We do have phone tutors available until 5:30 on Tuesdays and Wednesdays. We want to say thank you to Katie and Caitlin, right, for coming in this afternoon. Did you have some fun today?
Yes.
Do you think you would be able to tell some friends about Do the Math?
Yes.
That's what I need you to do. Deal?
Deal.
Deal. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District. with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.